Okay, here's where we ended up last time, and this is what we're starting off. Misleading graphs and statements. Graphs can be used to distort conclusions from data. Okay. Right here, and I left all the explanations on it so you could go back and not have to watch the video. You could just see it. The scale right here only goes from 80 to 86. So it's up 1 gram. And there's not a whole lot of difference between each of these. From the lowest to the highest, there's only about 3 grams. So not even 3. Is it? So, from this lowest, sorry, that is 3.3. All right. But it appears that this would be hugely better for your plants than this one, even though I doubt you'd be able to tell the difference if you were looking in your garden. Okay, right here, the other problem that they have on this one is that you go from 1 to 110, then 112, 14, 16, 18, 20, then to 40, then to 60. They don't use the same thing all along this scale. So that means you can exaggerate certain things. That right there is only 14 cents difference between them. 126 to that's 17 cents difference. But it looks a whole lot different on that other one. That other one looks minimal compared to this. So when you start messing around with your intervals, it starts being a misleading graph. This one does something I told you about on the circle. It doesn't add up to 100. You've got 5%, 10%, and 20%.
Are you there?
And so
Are you there?
it doesn't add up to 100, and
there?
therefore it's not going to be a valid graph.
Are you there?
Right here, statistics can also be misleading because of the way data is reported or graphed.
Are you there?
Okay? So,
Are you there?
right here it says, a researcher surveys people leaving a basketball game about what they like to watch on TV. Explain why the following statement is misleading. 80% of people like to watch sports on TV. Well, the reason that would be misleading is you were interviewing people leaving a basketball game. So obviously they like to watch sports. If you ask them what they like to watch on TV, they're going to still like sports. Okay. Another thing that can be misleading in statistics is finding that there is a correlation and saying that one thing caused another to happen, called causation. Correlation versus causation is very important to realize. For instance, during this pandemic, it's been reported that having diabetes is a risk factor for making COVID-19 worse if you catch it. Diabetes does not, however, cause you to catch COVID-19. Okay. So right here, when there's a correlation, the two events are related. When there is a causation, one event is shown to be the direct cause of another event. While a correlation between two events can be shown pretty easily, causation is much more difficult to prove. Studies have shown that students are less energetic after they eat lunch. There's a correlation there, but it ignores other factors that might have a causal influence. If I lift weights, I can make the football team. There's a correlation, but there are more factors involved. When the sun is visible, we have daylight. So it's a good way to determine causation is to look for other alternatives that could cause daylight. Since there are none, it shows causation. And that is something that you need to pay attention to in terms of how they can sway you by using misleading charts and statements.